we know that phi is equal to 2 pi into p divided by lambda, where p is called as the path difference and lambda is called as the wavelength of light. So if I take this and substitute it there, I'll get 2 pi into p divided by lambda, because phi is equal to 2 pi into p divided by lambda. We already know that phi is equal to 2 times n into pi. So this 2 pi and 2 pi will get cancelled. From this we will get the path difference is equal to n times lambda. So this is an other condition. So there are two conditions for constructive interference. One is phi should be equal to 2n pi, and the second is path difference should be equal to n into lambda, where in both the cases n belongs to z, where z is the integer set. So we need to have this condition in our mind to derive other expressions as well as solving problems. In a similar way, when I talk about destructive interference. So when we talk about destructive interference, it is the place where there is a dark spot that is formed, right? So we know the expression I is equal to I1 plus I2 plus 2 times root of I1 into I2 into cos phi. So for dark spot to be formed, the intensity should be the least. So intensity will be least when cos phi is least. So cos phi is equal to, what is going to happen here is, it should be minus 1, which implies phi should be equal to pi, or I can say plus or minus pi, plus or minus 3 pi, plus or minus 5 pi. It keeps on going like this. So phi should be an odd multiple of pi. So when I say odd multiple of pi, it can either be 2n plus 1 times pi or 2n minus 1 times pi. So there is a reason I'm telling this, because some books use this, some books use this. But I'll tell you the technique of which one to be used at which point when we solve problems. So as of now, you can write both. So it is 2n plus 1 pi or 2n minus 1 into pi. Both represent odd multiples of pi. And this is the condition for destructive interference in terms of phase difference. Similarly, we know that phi is equal to 2 pi into p divided by lambda. So if I write this as 2n plus 1 into pi, or phi is equal to 2 pi into p divided by lambda, which I will write it in terms of 2n minus 1 into pi. In both the scenarios, let's see what is going to happen. Here pi and pi will get cancelled, which implies p is equal to 2n plus 1 into lambda divided by 2. So this is one of the conditions for path difference. And in the second case, if you see, pi and pi will get cancelled, which implies p is equal to 2n minus 1 into lambda divided by 2. So this is an other condition. So what happens here is, either of them is the condition for path difference for destructive interference pattern. For destructive interference to take place, again there are two conditions. What are they? Phi should be equal to 2n plus 1 into pi or 2n minus 1 into pi, and path difference should be equal to 2n plus 1 into lambda divided by 2 or 2n minus 1 into lambda divided by 2. So these are the conditions for destructive interference.